Welcome to Graphs and Transformation of the A-Level H2 Math syllabus. In this video over here, I want to give you a brief overview of what to expect for this whole chapter, as well as talk about the first portion that we're going to be going through. Okay, so this whole entire chapter can be broken down into three main portions. So the first portion is actually all your basics of sketching. Okay, so I would just call it sketching, right? The second one is actually all your shapes or conics. Okay, so you can just think of it that way. And then the last part is actually your transformation and scaling. So there are three different portions. We are going to be going through the first portion first, which is your basics of sketching, right? And under the basics of sketching, the first few concepts will be your restriction, which is what we're going to be going through now. And then you have your x-intercept, and then you have your y-intercept, and then you have your stationary points, and then so on and so forth, right? And then I'll let you know once we are done with the basics of sketching, but essentially basics of sketching is what we are going to be focusing on right now. All right, so let's talk about what restriction is. Restriction is basically what values x can take on and cannot take on. So I give you an example. Let's say I have this graph, y equals to 1 over x minus 1. Okay, just a simple sketch like that. What do you expect this graph to look like, right? So if I open this up, it's a reciprocal graph, right? I put y, I put x over here. You expect this graph to look like this, like that, and then maybe like that. Yeah, I just got to draw a little bit better, right? And you see that this line over here is actually x equals to 1. Yeah, you see that this line over here is actually x equals to 1. Now, you realize that for every value of x over here, right? Every single value of x. So if let's say I take this x value, 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 all of them have a corresponding value of y. Or every single one of them have a corresponding value of y. Except for here, right? When x equals to 1, there is no corresponding y value. And why is there no corresponding y value in this example over here? It's because when x equals to 1, right? If you look at this, when x equals to 1, let's say we sub x equals to 1 into the equation, right? We get that y when x equals to 1 is 1 over 1 minus 1, which becomes 1 over 0. And we know that we cannot take a number divided by 0 because that will give us infinity, right? It's called the error division by 0. You cannot divide anything by 0, right? So we know that this one is undefined. And since it's undefined, there is no specific value of y. That's why you see over here, in other words, y does not exist when x equals to 1. It's as simple as that, right? So in other words, restriction is what values x can take on and x cannot take on. So in this case, right, what is the restriction of this graph? The restriction of this graph will specifically be x cannot be 1, right? That's the restriction of this graph because x can be any other value except 1. Okay, so that's the idea behind it. And as a JC student, you will have access to your GC, your graphic calculator. So I'm going to be showing you using these example questions over here right now, how easy it is to answer these type of questions using your GC. Okay, so feel free to pause this video right now to tackle this, and when you're ready, I will run through the answer together with you. Alright, so for the first graph, y equals to ln x plus 1, right? How do you actually use your GC to manipulate this? So I'm gonna show you, right? So this should be how your GC looks like. I'm just using the online version, right? So first thing, you go to here, and then you click ln. So you click ln x, let me just double confirm, x plus 1, yeah, x plus 1 plus 1, and then you close the bracket, and then over here you click graph, right? So you see that this whole graph exists except to the point where x equals to -1, right? So the graph cannot exist when x equals to -1. So if I were to just draw the graph over here, right, how will it look like? So this is y, this is x, and then over here it looks something like that, right? Or wait, I'm gonna draw to scale here, yeah. It passes through the origin, so it looks something like this, whereby here this is -1, right? It does not exist. So this is the portion where it exists. So the restrictions for this over here is we know that it exists anywhere above x equals to -1, right? And then from here and before, it does not exist. So the restriction for this, we will just say that x must be bigger than -1, right? When we say this, it implies that x cannot be -1 or less, right? It implies this. So this is good enough for here. And then for the next graph over here, x minus 1, x minus 3. So come back here. Okay, let's say I go down to here, and then I click alpha F1 enter to create a fraction. X minus 1 down, x minus 3, and then we take a look at the red color graph, you see that I get a reciprocal graph over here, right? And if I were to sketch out this reciprocal graph over here, right? Let me just enlarge the screen. You see that it looks like this. So it comes here and then it comes here, right? And then over here, you have x equals to 3 as the vertical asymptote, right? Which is very similar to the example that I gave over here. So you can see that in this case, all these x values, they exist, and all these x values that exist, and all these x values have a corresponding y value, except for here, right? Y does not exist along this line. So therefore, for y equals to x minus 1, x minus 3, right? X cannot be 3 because there's simply just no y value over there, right? And with that, it concludes the concept of restriction. Let me know if you got any questions. If not, I'll see you in the next video.